final example. A car lot needs to choose what cars to order for selling on their lot. They've got two options: the nice, which they purchase at $20,000 and sell at $30,000, and the superfine, which they purchase at $50,000 and sell at $65,000. If they have a total budget of $2.9 million for purchasing cars and 100 spots on the lot for new cars, how many of each car should they buy to maximize profit? Assume that they manage to sell whatever they purchase. So the idea here is they purchase a car and then they mark it up and they sell it. And so the difference between those two is how much money they make. But they've got limits on how much money they start with for purchasing cars and how many spots they have to actually put the cars on the lot. So they have to figure out what is the best combination of cars to purchase to be able to maximize how much money they make out of it. So with all this in mind, let's start setting some things up. So first, we're going to have to figure out how many numbers of nice they buy. So let's say N is going to be the symbol that we use for saying the number of nice cars that they buy, right? The nice cars that they buy will be N, however many that is. And then the superfines that they buy, S will symbolize the number of superfines that they buy. Okay. Now, another thing that we've got here is we've got a lot of really big numbers, right? 30,000, 20,000, 50,000, 65,000, $2.9 million. Now, we could work with the numbers as they actually are, and everything would wind up working out, but we'd have this extra factor of 1,000 showing up, right? All of these things are divisible by 1,000. So I'm going to say, why don't we make things a little bit easier on ourselves? And since we're dealing with lots of money, right? We're dealing with all these big things measured in the thousands, tens of thousands. Let's convert everything. So for ease, let's work in terms of thousands of dollars. So let's talk about everything in terms of how many K it is. How many thousand, right? K, killa, thousand. So how many $1,000 everything is. Okay, so that'll make things a little bit easier just in how many zeros we have to write down. So next, let's figure out how much profit do they make off of a single nice, right? Because what we want to do is we want to maximize the profit. So we need to create some function P that is going to be P equals the profit. So we need to come up with some equation that describes P in terms of how many nice and how many superfines they buy, how much N and S we have to go around, because we know for sure they'll sell all of them. So how much profit do they make if they buy such a number of, nice and such a number of superfines? So first we have to figure out how much profit do they make off of selling a nice, how much profit do they make off of selling a superfine. So a nice, if they buy a nice, it costs them 20K, right? It costs them 20,000. Costs them 20,000, which is 20K in our new form. They can sell that for 30K, which would net them a profit of the amount that they sold it for minus the amount that they had to buy it for. So that would net them a profit of 10K. For the superfines, they cost them 50K to buy. They sell them at 65K, so each one they sell is going to net them a profit of 15K. Okay, so with this in mind, let's write P in green for good old American greenbacks, since we're dealing with US dollars here. So P equals 10 times N, the number of nices that we sell, plus 15 times S, the number of superfines that we sell. Because remember, for each nice we sell, we manage to make 10K. For each superfine we sell, we manage to make 15K. So the total profit is going to be 10N plus 15S K. But we don't have to worry about the Ks now. Right, we won't worry about it when we're actually dealing with the numbers, the fact that they have the unit of dollars, thousands of dollars. All right, but there are some restrictions here. We were told that there's a restriction of $2.9 million for purchasing cars. So they don't just have unlimited amounts of money to buy on cars, right? If they had unlimited amounts of money, they'd want to stock their entire car lot with nothing but superfines. So they'd want to just fill the thing all up with superfines, but they have a cost to these things. So we have to deal with that. So if it's $2.9 million for purchasing cars, then $2.9 million for purchasing cars, well, each nice that we buy is going to be 20N. And each superfine that we buy is going to cause us to spend 50 S. So 20N plus 50S is how much we've spent on cars. Now they can spend up to 2.9 million, right? So 20N plus 50S has to be less than or equal to their total budget. And their total budget is 2.9 million, which we can write out as 2,900, because 2.9 million is the same thing as 2,900,000. So since we divided everything by 1,000, we're now dealing with 2,900. All right. Another piece of information that we had was that there are only 100 spots on the lot. So there is a maximum number of spots that they can fit cars into. So if that's the case, if they only have 100 spots to fit cars into, well then the number of nices that we're buying plus the number of superfines that we're buying has to be less than or equal to 100, because they can only fit up to 100 of these cars on the lot. So that's 2 requirements so far. Now there's 2 hidden requirements that we might not see, but it'll make it easier to actually graph the thing. Think about this. Is it possible to have a negative number of nices? Can they buy negative cars? No. The lowest number of nices that they can buy, or the lowest number of any car that they can buy, is 0. So we know that however many nices that they buy, it has to be greater than or equal to 0, and similarly S must be greater than or equal to 0. So we've got 4 requirements on this. The amount of money they have to spend, 20N plus 50S, has to be less than or equal to 2,900. N plus S has to be less than or equal to 100, right, the number of spots on the lot, and the fact that they can't buy negative cars. N has to be greater than or equal to 0, S has to be greater than or equal to 0, and our objective function that we're trying to maximize, because we want to maximize our profit, and our profit is this P equals 10N plus 15S. So we want to maximize P. All right, so at this point, we bring to bear the power of linear programming. So first, let's convert some of this stuff into things that we can easily graph. So let's make, if we're going to graph this, so we can see what's going on, we've got to choose some guy to be horizontal and some guy to be vertical. So just arbitrarily, let's make N the horizontal, S the vertical. So N gets to be horizontal, S is vertical. So with this idea in mind, we can now talk about ordered pairs that come in the form N comma S. Just as X comma Y, horizontal comma vertical, since we made N horizontal, we made S vertical, it's going to come in N comma S. Now there's no reason it couldn't be flipped, but we just chose one and we stick to it. And as long as we stick to it, it'll work out. Okay, so at this point, if that's the case, then since S is the vertical, we normally solve for Y, the vertical, in terms of other stuff. So we want to solve for S, the vertical, in terms of other stuff, because that's what we're used to. So N plus S is less than or equal to 100 means that S has to be less than or equal to negative N plus 100. 20N plus 50S is less than or equal to 2,900. 50S is less than or equal to negative 20N plus 2,900. We divide both sides by 50. We've got S is less than or equal to negative 2/5 N plus 2,900 divided by 50 becomes 50. Sorry, give me just a second. Yeah, becomes 58. Had to use a calculator for that one. So 2,900 divided by 50 becomes 58. So we've got S is less than or equal to negative 2/5 N plus 58. So with this in mind, we've got enough to be able to see what we're allowed to go for here. So if N has to be greater than or equal to 0, then we've got this graphed, if N has to be greater than or equal to 0, this is actually going to be the green one. So for a second, forget about that mistake. So N has to be greater than or equal to 0, so we set N equal to 0, we draw a line, S is allowed to go wherever it wants. So everything on this side is fine and dandy by our N greater than 0. S has to be greater than or equal to 0. We set a line S equal to 0. Everything greater than that, fine and dandy by S greater than or equal to 0. Now, the interesting parts are actually going to wind up being the S less than or equal to negative N plus 100. So if that's the case, we can just sort of get a good sense of this. So let's say 100 is up here. At negative 1, it marches down like this. Right, 45-degree angle. And we know that S has to be less than or equal to negative N plus 100, so it will be below this. And S is less than or equal to negative 2/5 N plus 58, so it's going to start at a y-intercept height of 58, but it goes much less steeply down at negative 2/5. So it goes like that, and it also will allow for the part below it. So the total set of things that's allowed is this highlighted part in yellow. However, the only things that are really going to be interesting are going to be our vertices. The vertex here, 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 and here. I'll circle those in yellow just to make them a little bit more obvious, but it's probably becoming pretty hard to see through the loudness of those colors. But we've got an idea of those corners. Now, notice 0, 0 is one of the points. We've got an origin corner. Is it possible to make any money if we plug that into P equals 0, as 0 for N and 0 for S if we buy no cars to sell? No, we can't make any money. So we only have 3 things to care about: where red intersects green, where red intersects blue, and where blue intersects purple. So if that's the case, let's look at red intersects green first. So that is -2/5 N plus 58 gives us N greater than or equal to 0. So if that's the case, if it's N greater than or equal to 0, so that's a little bit difficult because we're set up for solving for S, right? So where is that going to intersect? Well, at N greater than or equal to 0, we want to figure out at N greater than or equal to 0, we want to figure out what that comes out to be. So if S is equal to -2/5 times 0 plus 58, right? If we know this is going to be equal to S and N greater than or equal to 0, we can treat as N equals 0 because we're only dealing with lines here. So we plug that in here. So we've got -2/5 times 0 plus 58 equals S. So 58S and N of 0. So the point that we get out of this is going to be N0, 58S. So 0, 58 is one of our points so far. Next up, let's look at where the blue intersects the purple. So -N plus 100 equals, the purple had a height of S0, right? No height at all. So that's just going to be 0. So 100 equals N. So that means we've got 100, 0, because if we were to plug that into N plus S, right, N plus S equals 100, since we're dealing with the lines now. If we plugged in that, we'd have 100 plus S equals 100, so therefore S equals 0. So we've got 100, 0. So notice that these are the two extremes possible for the car lot to sell. It could sell all superfines, right? It could sell nothing but superfines, and it has a maximum amount of money that it can spend, right? 2.9 million. So it can't buy its lot entirely full of superfines. It could only have 58 superfines on the lot before it would run out of money to purchase cars with. On the other hand, it could buy 100 of the Naises and it would still have money left over, but it's run out of spots on the lot. So it could buy 100 Naises and no superfines and have extra money left over, or it could buy, the lot could buy all superfines and run out of money before it runs out of spots. So it would have 58 superfines, but still that gives us another 42 spots left for Naises. So those are the two extremes possible so far. Finally, we could also have the possibility of if we have the blue and the red intersect. So if we had -N plus 100 equal to -2/5 plus 58. No, sorry, -2/5 N plus 58. So we can multiply everything by 5 just to make it a little bit easier on us. -5N plus 500 equals -2N plus 58. We turn to a calculator, figure out what 58 times 5 is. We get 290. So 290 out of that. We add 5N to both sides. We subtract by 290 on both sides. 500 minus 290 gets us 210. We add 5N to both sides. That gets us 3N. So that gets us, dividing by 3, sorry, not 80, but 70 equals N. We use that to figure out how many superfines that would bring us. So by our lot equation of S is less than or equal to -N plus 100, we want to be on the line equals. So S equals -N plus 100. So S equals -70 plus 100, or S equals 30. So the three possibilities are 0, 58, 100, 0, and 70, 30. So at this point, we just want to actually plug each one of them in and figure out which of these works best. So let's start with the point that we've arbitrarily made the red point. So if we sell nothing but superfines, we spend all of our money on superfines, then that's 10 times 0 plus 58, 10 times 0 plus 15 times 58, just so we keep up the same pattern. 15 times 58 becomes 870. So we would make a total of $870,000 at the lot if we bought nothing but superfines. Next, we'll do the one that we arbitrarily made the blue point. So the profit out of that one would be 10 times 100 plus 15 times 0, the number of superfines. So the profit that we'd make off the lot would be 1,000 plus 0. So if we sold nothing but nices, we would be able to get 1,000 or 1 million off of our sales. But what if we sold a combination of nice and superfine? So if we sold a combination, the one we arbitrarily made the green point, then our profit would be 10 times 70 plus 15 times 30, right? 10 is the profit from the nices, 15 is the profit from the superfines. We're selling 70 nices, 30 superfines. We know that's possible because it's on our vertex. So that gets us 700 plus 15 times 30 is 300 plus 150, 450. So a total profit of 1,150,000. So 70 and 30. So the optimum solution for maximum profit is sell 70 nices and 30 superfines. And if you're curious, that came out to be a profit of 1,150,000. So the total profit, the maximum possible profit for the lot, will wind up being $1,150 million. All right, cool. All right, so that finishes up for linear inequalities. There's this idea of linear programming, and there's also just being able to figure out what are the things that our linear inequality allows for. Linear programming is a great thing that we can use all of our information about linear inequalities for, but you can also just work with linear inequalities. All right, we'll see you at Educator.com later. Bye.